This is a right triangle. It's a right triangle that has a few things to it. Namely, it has what is known as a leg and another leg. Now these two legs make up the right angle in a right triangle. It's called a right triangle because it has one 90-degree angle. The side opposite the right angle is called the hypotenuse. These are the parts of a right triangle. Now we use letters on a right triangle, namely A and B are letters that are used to identify the legs, and C is the hypotenuse. And so we have one definition to share with you for this particular concept, and that is the definition of the Pythagorean theorem. Now the Pythagorean theorem is a formula that proves triangles as right triangles, and it goes like this: a squared plus b squared is equal to c squared, where a and b are the legs and c is the hypotenuse. In this concept, we're going to use the Pythagorean theorem, and you're going to be using this a lot in geometry as well. So let's talk about a right triangle with a leg of 3, a leg of 4, and we have to find the hypotenuse. This is how we could draw the triangle. Now to use the Pythagorean theorem, we would go and square one of the legs, and to that we would add the square of the other leg and set it equal to x squared. How do we solve an equation like this? Well, if we square 3, that gives us 9, and if we square 4, that gives us 16. Now, if we add 9 and 16 together, that gives us 25 is equal to x squared. And since this is an x squared or a quadratic equation, I have to find the two answers. Now, when we see an x squared where we don't have an x term or anything else, what we can do is, once the x squared term is isolated, we can take the square root of both sides. Now, the square root of x squared is just x. And the square root of 25 is actually plus n minus 5. But because this is a geometry question, we say that the result of the hypotenuse is just 5. So we want to look at equations that have just an x squared in them and try to be able to solve them. Okay? Here's our next example. X squared is equal to 169. If we notice the x squared is already by itself, so we're just going to go and take the square root of both sides. So the square root of x squared is x, and what is the square root of 169? Well, it's 13. And since it has to have two answers, it'd be plus and minus 13. So what if the x squared term is not by itself, like 5x squared is equal to 80? Well, we make the x squared term by itself by dividing both sides by 5. This gives us, then, x squared is equal to 16. And now, same thing as last time, take the square root of both sides, and x is equal to plus and minus 4. So here's a situation where, well, we don't have anything squared other than the x. X squared plus 18 is equal to 30. So if we took 18 away from both sides, we would have x squared is equal to 12. Now I have to take the square root of both sides. So the square root of x squared is x, but the square root of 12, remember, breaks down into the square root of 4 and the square root of 3. So x is going to be equal to plus and minus. The square root of 4 is 2. The square root of 3, we don't know. So these are our three solutions. Notice once we had x squared completely by itself, that we could go ahead and take the square root each and every time. Here's two final ones for you. Let's take a look at 3 squared plus x squared is equal to 8 squared. 3 squared is 9. The x squared stays, but we know 8 squared is 64. Now I've got to isolate this x squared, so what I'm going to have to do is take 9 away from both sides. And the 9's will go away. I'm left with x squared is equal to 55. Take the square root and think, are there any perfect squares in 55? And the answer is, well, no. So our answer is plus and minus the square root of 55. And finally, here is x squared plus the quantity 2x quantity squared is equal to 80. So order of operations tells us that we need to square anything in parentheses first. So it's going to give us x squared. And if we square 2x, we're going to get 4x squared. Now, everything on the left side has an x squared, so we can combine those. That's 5x squared, because this is a 1 in front of x squared, is equal to 80. We've seen one like this before, the one above. If we divide by 5 again, we get x squared is equal to 16, and we can take the square root of both sides, giving us x equals plus and minus 4. So you have 2 for practice at the bottom of your page, and go ahead and pause the video and go ahead and try those 2, and then I'll be back with you again and we'll go through the answers. Okay, here's our first one. X squared plus 7 squared, which is 49, is equal to 9 squared, which is 81. If I take 49 away from both sides, I'm going to get x squared is equal to 32, and then take the square root. Well, 32 has a pretty big perfect square in it, namely 16 times 2. So x becomes then plus and minus 4 square root of 2, because the square root of 16 is 4, and the square root of 2 we don't know. Second one had a right triangle of legs with 4 and 5, and we had to find the hypotenuse, which we'll call it x. So this formula or equation would be 4 squared plus 5 squared is equal to x squared. Squaring each item gives us 16 and 25, and adding the sum of 16 and 25 is 41. We take the square root. Because this is a geometry question, we're only going to have a positive answer. And that positive answer is the square root of 41. Length cannot be negative, and so we have found the missing side of the right triangle. And that is the Pythagorean theorem and simplifying quadratic equations by taking and using the square root.